Hey guys, welcome back to the channel. Back with the post. So the last time I remember we have done this problem, count binary substring. So we are gonna do k different pairs in an array this today. Okay. And for your information, this uh, this entire list is composed of problems that are supposed to help us understand and identify the patterns within the data structures and algorithms and within the problem. So lead code 532, it's a medium level problem, and it is said k different pairs in an array. The problem is k different pairs in an array. So the problem statement is we were given an array of integers and an integer k. Okay, so here an array called nums and an integer k. Return the number of unique k different pairs. Oh, unique. Okay, k different pairs in the array. Okay, a k different pair is an integer pair where the following are true: I and j lies between 0 and length of the numbers, and I should not be equals to j, and the difference between these two, ith element and jth element, should be k. So we have to, I think we have, I did it, but let's see. How do I know whether or not? Okay, let's see. Submission join lead code. Okay, sorry guys, sorry. Let me log in. Right. Let's see if it is done. I think it's not touched. So I, I just feels like it's been done already by me. Well, what is that? Well, denotes the absolute value. Okay, I know it. So let's go. What are we gonna do? Here k is 2 and the difference between uh, a pair should be 2, right? So 3 and 1 is 2, 3 and 1 is 2 again, 5 and 3 is also 2. So 3 and 1 has been already taken, so we are ignoring the second one, and 3 and 5 it seems. So there are two unique pairs. So let's do it. Let's sort the list first. So okay, we have sorted it, and 0. So for so so or minus. So since we have sorted it, the list will be in the ascending order. So R will be starting from 1 and L will be starting from 0. And let's see the difference. If the difference is the difference is less than, Let's do one thing. If difference is less than k, why go such length? If the difference is equals to k, we forgot to keep count. Let's count, and let's do another thing. If both the r and r minus 1 are same, it's better to skip all the duplicates. If nums of r minus nums of n, yeah, if it is greater than k, then we should increase the left bound, right? Also, let's check. Let's check if it works, and if it works, we'll submit and start discussing the intuition. Well, it seems like it's working for few cases, and let's debug it. So let's see. So it's been sorted, and we are at R and L will be on 0 and 1. Let's do another thing. Let's keep it like this, and also let's see how R and L are moving. So initially 0 and 1. So k equals to 0. So it works for 1 and 1. And oh, and R and L are 2 and 2. It should not happen. Okay, if both are equal, let's keep a left and or right. It will be much cleaner. So right. So this is why this happened is we should not or should not be equal to L, but so we can count it once. So let's see now how it works. So this ruined it. In this case, k is to 0, 1. One equal to 0 should be an edge case. If the difference is greater than k, then we are incrementing L. Also, we didn't check the constants. Length of numbers will be between 1 and 10 to the power of 4 and great. So the elements will might be 0 minus also negatives also. So while r minus while this is greater than k and L is less than r. Let's call this distance. If the distance is greater than k, if the distance equals k, okay. Let's think it through again. So I should be less than j. If the distance equals to k and L does not equals to r, we are incrementing the count. If the distance is greater than k, then we are reducing L until we get. Okay, got it, I got it, I got it, I got it. I mean, after seeing the constants, this might cause a problem. because if it contains negative values, after sorting, negatives will be at the left side and positives will be at the right side, and then negative positive minus negative will be a positive value which might be greater than 0 or greater than k. So it should do like this: 3 minus 1, then r increments to 4, and l should also increment. The distance is equals to k. And if L does not equal to R, we increment the count. If the absolute difference is greater than K, then we are increasing the left bound. Okay, if now so 4 minus 1, if both are same, 4 minus 1. So let's dry run the example here and let's see what's happening. Actually, the distance, let's see, R and L are 0 and 1. So the distance is 0. Then we go to the next loop. If If the difference, absolute difference, is greater than k, it fails. And we come to the next condition. If r and l are same, then we are incrementing the r until it becomes different. So increment it to 3. I mean, it should be incremented to 2. I think we should keep a continue here. What should we do? It should be done previously itself. Mm, 1122. I think we should keep it here itself, and this too. If we increase the left one and the absolute different increases or decrease, okay. Guys, we should not do this. Yeah, we should not do this. Because if we have negative numbers, one, one, two, three. But if we have minus 3 and 2, the difference increases by a very huge extent. I mean, very large number. The difference will be in a very large number. Why does it feel like I did it and I'm unable to do it right now? Mm, two and three. So what are the binary fetch setting two pointers? I strongly believe that it can be done in order of an here the difference is 3 1 we are good until sorting but this distance equals to k and I not equals to j aside here, then we are counting it. It's absolutely different. A key difference in the k difference horizontal here. In the k different pairs in an array, number of k different pairs, three different pairs, 1 3 and 3 5. So 1 3 1 3. Okay, okay. We can allow it once but not twice. Nah, let's do one thing. Let's not struggle too much and just see the distance. Also, let's add a negative. Okay, minus 6 and minus 4. The distance is 2. Minus 6 and minus 3. Distance is 3. Okay, is 2, right? So it goes, as R goes right side, the distance keeps increasing. So okay, so it worked here. 0 and 1, distance is 0. 0 and 2, distance is 2. 0 and 3. Okay, so now L increased. Now 4 and 1, right? Let's also add a test case where we have two threes. Right, it failed. So 1 3, and it comes to 1 and 4. The difference is 3. Here the difference is 3. The difference is 1. 0 1 2. So L is shifted to 2 and R increased. Sorry, at 0 and 3 the difference is 3. So between 2 and 5 the difference is 2. So okay, and let's dissect why we are getting these wrong answers. 0 and 1 difference is 1. 0 and 2 difference is 2. As we increase L, 0 1. The difference increases. 1 and 3. Right. This is causing a problem. This should not increase like this. Uh, but if we make it a for loop, then we cannot increment r. Right. So, let's check this out. Well, it is working now. So we are avoiding duplicate successfully. And let's see what's going wrong here. So here 0 and 1. The difference is 2. Now for 0 and 2. The distance. So if we find any duplicates, we will continue. And if the count exits, we're incrementing L. 0 and 1, 1. Now 0 and 2. It comes here and distance is useless. So let's see what's happening in this case. Where k is 0. So let's consider it as an edge case and 1 and 1. It only won't work in this case. So we shall handle this case carefully. K will be between 0 and 10 to the power of 7, right? we need distinct pair of duplicates in case of k equals to 0. I know this case can be handled elegantly. Like I couldn't. So let's reflect on what we have done. So we're going like this, and if k equals to 0, we have to consider 1 time. So how do we handle this case? Only this case. I'm sure the remaining cases were handled properly, even the ones that include negatives. But if k equals to 0, then we have to include duplicates. If k equals to 0, then we have to increment the count. This should give 3. But if we add the condition, no, this will cause the problem. If counted, if not counted, then we'll count. Now let's see. Right. So it's working. Let's try submitting it and check if it works fine. And if it works fine, then let's discuss the intuition. Right, it is working fine, and it seems that time and space complexity is also working fine. But I'm sure it can be written more elegantly. So let's see another other solution. So if k is less than 0, wait a minute. K will be between 0 and 10 to the power of 7. This is an invalid edge guess. And count equals to 0, insulated count equals to 0. Okay. If count is 0, great. This is pretty useless, guys, because he's keeping every uh, pair of set into a record, which will increase the space complexity by a very huge amount. Let's do one thing. Let's check in this part. Okay. So he sorted it. He kept a stack and a result. Okay. He's calculating the absolute distance. If the value is less than k, or if r and l are same, then increasing r. Else, if the distance is greater than k, then increasing l. Okay. Else, result. That means value and k are, if the distance and k are same, then increasing the count and increasing l, and checking if l and l minus 1 are same or not. If both are same, then increasing l and increasing r to l plus 1. This is also not looking very elegant. In fact, ours is a bit elegant, so let's discuss our approach. So we are initially sorting the numbers array and initialized left hand count and a boolean value counted. So initially, if uh, if the consecutive numbers, since they are sorted, if the consecutive numbers are same, I mean if there are duplicates, then we are checking if k is equals to 0. Actually, instead of doing this thing, it's better to add the edge case. Let's keep it like that only. Elegant or not, it is working and it's in the better condition. So I hope you guys understand the intuition. So that's it, guys. Uh, we'll get back with another problem. Bye, guys. Keep pushing hard and keep learning.